We're continuing the final exam review. Okay, find the domain. Domain. What does that mean? And this is that has to do with graphing. You see, this is a function, and this is function notation. And this really just means y equals blah, blah, blah. When x is whatever, what does y equal? And you can graph this. You know, if x is 1, could you plug it in and figure out what y is? Yes, you could. If x is 2, you know, et cetera, et cetera. But the domain has to do with, you know, if you have a graph like this, what if I told you your graph looks like, you know, this, even if it's a curve? What if I told you this? Then I would ask you, hey, what's the domain? Domain is what can x be? This is really the importance of, as far as really understanding this, what can x be? What can you plug in for x? If you look at this graph, this is your x-axis. Do you see how x can be anything from negative infinity to positive infinity? This thing goes on forever. Or if you have a graph like this, and I'll get rid of all this stuff. But what if you have a graph like this? These are the kind of graphs you guys are used to. You know, when x is 1,000,000, could you plug it into the equation and get a y? You see, this goes on forever because the arrow tells you it does. But what if you have a graph like this, where there's just a circle over here? You see, what can x be? Can x be -5? If you have x is -5, y doesn't exist. You see what I'm saying? So x can be anything between these values here, from here to here. Anything on this line here, from here to here, is what x can be. That's what a domain has to do with. Or if you have a graph like this, this is a... I need to go potty with my grandcracker. You really shouldn't go potty with your grandcracker. Do you see how this is the square? This is actually a square root graph. What can x be? In this case, x can't be anything that's negative, you see? Because this is the picture of it. This ends right here. It tells you it does, you know? So anyway, so here, x can be any positive number. So anyway, so the domain has to do with what can x be. I'm sorry, I'm gonna have to pause for just a second. My son needs me. Okay, resuming recording. What can x be? That's the domain. So then I tell people, what can x not be? And when you look at this, what do you know? You can never have, this is a fraction, you know. So even if you just go
here in the denominator.
Say that again, Amber?
You can't have a 0 in the denominator.
Perfect. So the numerator over the 0 is a big fat no. You cannot have a 0 in the denominator. So what you have to say is, what can x not be? Anything that causes a 0 in the denominator.
Mm-hmm.
That's what x cannot be. Undefined. Yes? So this is not okay. This is not allowed. So you have to avoid it. So what we're going to do is you set the denominator equal to 0, and then you're going to exclude anything you find from that, because that's what's not okay. So you say x cubed minus x squared minus 2x equals 0. And then at the time you didn't know how to do anything else, so you're going to factor and solve. They all have an x. And then open, close, open, close. Product is -2. This is another mini review. Sum is -1. You finish it while I pause. Okay, as long as I don't forget to hit record in the middle. Okay, so did you find the numbers? I need a -2 for product, so -2 plus 1. -2 times 1 is -2. -2 plus 1 is -1 true. So you put them in there, x negative 2, x positive 1. Then you have a times b times c equals 0. So if any one of those equals 0, it makes a statement true, right? That's a zero factor law. So x could be 0, or x minus 2 could be 0, or x plus 1 could be 0. And then you have x is 2, isolate each one, right? And then the tricky thing here is that you understand that what we just did is actually find all the values that we can't use. So people struggle with that a little bit because they're like, well, these are the answers. I'm like, no, these are the specific values that if you plug them back into this original, they cause a 0 in the bottom, and then you have a problem. You see, look at this. If x is 0, 0 cubed minus 0 squared minus 2 times 0 is 0, illegal. If x is 2, you get a 2 cubed, which is 8. 8 minus 4 is 0, etc. You know. So what you're going to say is, it's going to ask you what is the domain, and you're going to say for final answer, the domain is, and this here, I didn't mean domain is 0. I meant that is the denominator, okay? So that could be a little bit confusing. I meant the denominator here with that d. But the domain is x such that x is real. It has to be a real number. And x cannot be, and you can put them in order or not, the computer won't care, negative 1, 0, or 2. And then in my math lab, it should have a spot where you just put those values in. How we doing?
Mm-hmm.
Yeah? So hopefully that helps folks understand what's going on here. But that's the only time when it's in function notation and they ask you about the domain. That's how you have to attack this one. So, yell if you have questions. Simplify the expression. So this is where I say, beginning of chapter 7, you have a numerator, you have a denominator, factor, factor, cancel, cancel. So, factor and cancel, yes? Factor, factor, cancel, cancel. So then I say, well, if you can't factor, then you're toast, because really this is, if you can't factor right now, you can't do any of this stuff. So we're going to factor the numerator. I say factor, you say greatest common factor. Is there one? Oh, they both have an x squared. X squared times what is x cubed? X. X squared times what is 11? X squared is 11. Yes? Then we have a denominator. I say factor, you say greatest common factor. There isn't one. Then you say, what is it? Oh, it's a trinomial. Oh, leading coefficient is 1, meaning it's simple. Simply open, close, x, x. Product is negative 77, and sum is positive 4. And then you fiddle with that 77 until you find a number. You know, 77 is fairly easy because 77, if you split it up, 1 times 77, or 77 is 7 times 11, and then you really don't have other options, and then it's going to work out, see? I need a negative, so it's going to be 11 minus 7 to get that positive 4. Yes? Order doesn't matter. And now you have a numerator denominator that happen to have a factor in common, right? And that's the one you're going to cancel, and your final answer is x squared over x minus 7. All is well in the world. I can move on. Oh, thanks, Amanda. Oh, well, I have to bake a cake somehow. And usually I do not let my child go to the bathroom with food, people. I really don't. Oops, I'm recording all this good stuff. just real life, you know.
It is.
We have a big rule that really the only food we eat in the kitchen or in the, we have a dining room here, that open floor plan, whatever. The only time it's really special for him to get to eat on the couch, and that's the crackers when I'm busy. Special times.
Yep.
But he usually doesn't haul them off to the bathroom. Okay, find the function value. So this time they're not asking you what's the domain. If they ask you what's the domain, you would say, oh, the domain is a half. X cannot be a half because 2 times a half is 1 and 1 minus 1 is 0, and that's illegal. But they're asking you to find the function value, and all you do is you plug that in. F of 8 is really, what is y when x is 8? So, you know, f of 8 is, so you could replace that with the y. You see, if you like that better. So it's, you're going to take the original and replace that x with that 8. You see, we're going to do that one in blue then. 8 plus 8, x is 8. So 2 times 8 minus 1. So 8 plus 8 is 16. And 2 times 8 is 16 minus 1 is 15. So what this really means is when x is 8, catch me if I'm wrong, I don't like that number.
That's what I got.
I'm so distracted today. Okay, when x is 8, y is 16/15. You see? So what this really means is in function notation, f of 8 is 16/15. That's it. So then we'll use a different color. Let's try f of 0. What is y when x is 0? You just replace, and don't tell me x can never be 0. X can't be 0 if it causes an undefined, if it causes a 0 in the denominator. Me putting this 0 in for the function is not a problem because look, we don't get a 0 in the denominator. Okay, so y is 8 over 2 times 0 is 0. 0 minus 1 is -1, so y is -8. Some students want to enter this in. And don't enter it like this fraction, all right, okay, unless it's necessary. This is not necessary, this simplifies. We need to do this into the computer, yes? And then the last one is f of -1. And you know, really, I could let you do this one by yourself. F of -1 is -1 plus 8 all over 2 times -1 minus 1. F of -1 is -1 plus 8 is 7. 2 times -1 is -2. -2 minus 1 is -3. And then the computer will want that negative in the front or in the bottom. And simplified improper fractions, not mixed numbers. Simplified improper. So if this were, you know, where these two have something in common, you do need to simplify. All is well?
Mm-hmm.
Okay. Find the quotient and simplify. Let me see what else is in here. And then see, now we're going into chapter 3. So what I want to do today, if that's okay with everyone, I would like to finish this. So I think this is the last one. And then just a little hint, because Amber was asking, you know, this is then graphing. Back when we did a lot of word problems in chapter 6, where we had to factor and solve. And then we did word problems in chapter 7, which you guys at that point, we had to abort that mission this semester. And then if you don't see any word problems here, maybe that's a clue that you got lucky this semester. Yes? Glück im Unglück. That thing. It's one of my favorite sayings. Those Germans. Just means luck and unluck. Sometimes you got to look at the positives, right? The positive is you don't have to fiddle with word problems this semester on the final exam. Okay, so find the quotient and simplify. I am, okay, so you always look at what am I doing? This is chapter 7 and I'm working with polynomials / factored stuff or whatever, and rational expressions. So back in the olden days, if you have A over B times C over D, you just go across. This is pre-algebra. And then we do the same thing, P over Q times R over S. This is then when they're polynomials or, you know, so this is the same exact thing. It's just they look a little different. And then what do we do if we divide? So if you divide, so if you're dividing rational expressions, then you keep the first one, you change the symbol from division to multiplication, and you flip the second one. And this is it for right. That's what this problem wants, right? Keep, change, flip. So this is no different than you saying, oh, I'm taking 2/3 and I'm dividing it by 5/9. And you say, oh, if I'm dividing, I have to keep the first one and then flip that around. And then what you do is you can say 2 times 9 is 18 and 3 times 5 is 15 and then simplify. Or you can say, oh, I could say that's a 2 times, the 9 is a 3 times 3, and this 3 is a 3, and this is a 5, cancel, cancel. And then you simplify and say 2 times 3 is 6 over 5, you see? So different ways of doing these. So what do you do here? You're going to say, oh, it's a quotient, or you recognize this is division. Yes, so that's a division symbol. It's a little hard to see. And then maybe I should have blown this one up some, but whatever, we'll manage. So you're going to keep the first one. And you're going to multiply, and you flip the second one. And then you're gonna say, I have a numerator and denominator. So this is now, we're actually technically, just like here, earlier we've just went across, you could just make that one long line and say factor, factor, cancel, cancel, you know? As you can with that division. So I don't like to keep that separate. The one thing I'm not going to do, some of you will want to FOIL this thing, so people get confused, what do I do when? The last thing you want to do is FOIL, because you're trying to create all multiplication, just like right here, so you can then cancel. So your goal is, you always got to think about what's your goal. Oh, you want to cancel everything at the end, so you need to create multiplication. If you FOIL this, you're just going to make yourself more work. So we're going to leave this alone. Then the 20. Okay, so we could say, some of you will say, hey, let me cancel that 20 and that 4. And I'm not against it, but I usually go ahead and factor, 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 and then cancel. So I like to factor everything all at once, if possible. So I'm going to take that 20, and I'm going to say it's a 2 times 10 and a 2 times 5. And I'm not saying you have to do it that way at all, okay? I just like to factor them completely. And then with the x to the 7th, you know, we can argue, do I want to split them all up into little x's? That can be annoying. So what do I do? You know, if I was going to follow this rule, I kind of technically have to break them all up, but I'm going to go ahead and leave it as a 7. And then I have a 4, which is a 2 times a 2, and I'm going to go ahead and let that x to the 6 be. And then how do you factor 5x minus 15?
Take out a 5.
Exactly, right? So 5x minus 15, I say factor, you say greatest common factor. So you just pull it, 5 times x is 5x, and 5 times negative 3 is negative 15. And that was my goal anyway. So now I have everything factored. Upstairs, downstairs, cancel, cancel. Upstairs, downstairs, upstairs, downstairs, upstairs, downstairs. And then you have to deal with the, what is x to the 7 over x to the 6, you know? That's just x technically upstairs, yeah, right? So you have an x times an x plus 4, and everything downstairs canceled, you see? So if you need an intermediate step, you could say that's x plus 4, x to the 7 all over x to the 6. But these two here will cancel into a simple x, and it's all upstairs, so it turns into this no matter what. And the computer doesn't want to see over 1. Yes? But again,
So if I put x squared plus 4x, that would have been wrong, right?
No, not at all. Actually, no, I'm glad you brought that up. Or, see, I paused too soon. Or you can distribute this through and call it x squared plus 4x. Either one of those is completely legal, and the computer will take them both.
Okay.